Welcome to exercise 1.2. Today we're gonna plot a simple graph, and therefore I'm gonna switch to the Matlab code. Here you can see the Matlab code which we already derived from the previous exercise. We have the same preamble, we have a description, the output, the version of that script, the revision and the start of the program. You already know all these code lines, and now I'm going to show you how to plot a graph from the results of the last exercise. Therefore, we first define a new section which is called plot parameters, and in this section we define our parameters. First we have to define our color. Our color is consistent of a vector with 3 entries, and this is the usual RGB code. Then we define the units. And the units are normalized. That means 0 means that you have 0% of the screen, and the 1 would mean that you have 100% of the screen. So the plot will adapt to your resolution of the screen. Now we have to define the line width of the plot. The line width is defined in a variable which is called line width, just without the vowels. Then we have to define the font size. And now we have to define the position of the figure. You define a position of a figure with 4 values. The first value is the distance from the left end of the screen. The second value is the distance from the bottom of the screen. The third value is the horizontal length, and the fourth value is the vertical width. And now we have to decide which title the graph should be. Since we want to display our results from our simulation, our title graph is going to be displacement and velocity versus time. And now we have 3 entries which define the name of our x-axis and the name of our first y-axis and the second y-axis. These are all our plot parameters that we need for our plot. If we run the section, we see that now in the workspace are all the variables we need. And we also see that in the command window the color and the units are displayed that actually we don't want to have. That's because we missed that semicolon here. Run again, and we see that everything is perfect now. Okay, the next section which we need for our plot is the plot graph section. And in this section we're going to define how our plot should look like. First of all, we need to create a blank figure, and this is done by the function figure. We can save the figure in the variable fig. You can use different options to define specific values to your figure, like the background color, which we already defined in the plot parameters. We have the units, which we already as well defined in the plot parameters. Then we have the position. And that's all we need for a blank plot, for a blank figure. If we run that now, we see that we just have a blank figure, which is almost over our whole screen, because our position figure is like 0.98 and 0.8. In the next line, we plot the actual figure with two y-axes. And we also define three output variables. We define the axis of the graph, so we can later manipulate them. Then we need the line of the first plot and the line of the second plot in order to manipulate them as well. And now we use the plot yy function to plot two different functions in one plot. The x-axis, the first x-axis is the time, and the first y-axis is the displacement x of t, and then the second x-axis is time again, and the second y-axis is the velocity. Now let's have a look what happened. Now we can see that we have already our results plotted into that graph. But at the moment it doesn't look really well, so we're going to manipulate it a little bit more. First of all, we set the color of the first line and the second line. In this case, K means black. We also define the line width. And now, in order to save a little bit of time, we can just copy it and manipulate it such that we have the line 2 now, and we want another color, which is red, and the corresponding R means red in the Matlab code. Then we have also to manipulate the axis. You can always manipulate lines and axes with the function set. In this case, we use the option Y color in order to set the color of the y-axis, which is black again. The line width and the font size is also given. And again, in order to save some time, we do it for the second axis like that, and we want red. Now we want to use our labels and set them to the plot. And in order to do that, we don't use the function set. We do use the function x label, where we have to specify the axis we want to label. And then you have to specify which title you want to use, and that's x-label graph. And of course, again, you have to say which font size you want to use. Okay. Now we're gonna do that for both Y labels as well. First, for the first graph, I want to use the Y label graph 1. So it's gonna put in the displacement x with m. And here we want to use, of course, the second Y label, which is gonna be like that. Put in the semicolons. And let's have a look what happened. Okay, now I have an undefined function or variable, so I probably have misspelled something. And you can see here in the line 66, there must be something wrong. Yeah. I misspelled the line width. Now everything is fine and it looks like this. But what you can see now is that you have here some points where the plot is really close to the axis, and that is not that beautiful. So we're gonna manipulate the limits of the y-axis. That's gonna be the last step of our manipulation. But first, I'm gonna define the title of our plot. You can use the function title and just put in our defined title. Now, in order to manipulate the limits of the y-axis, we have to get the maximum of the displacement, and therefore we gonna define as a variable xt maximum limit, and you can calculate that one with the maximum function, which gives you the maximum of what you put in here. And we want, of course, the absolute value of our displacement, so that we also get, if our minus value from x of t is in absolute case higher than the positive one, you also get the maximum of the displacement. And then, of course, we have to add a little bit in order to stress out our y-axis. Then we can just copy that bit of code. Alright, and then you can use the function y limit in order to limit your y-axis. First of all, you have to specify again which axis you want to use. This is axis graph 1. And then you have to specify the limits you want to use. And we put in our variable for the minus of that variable for the negative limit, and the variable itself for the positive limit. So now we have to define these limits, and of course, because we have two y-axes, we also need to do that for the velocity. And in order to do that, we can save some time, so that we just manipulate this bit of code such a way that we now have our velocity. And of course we want to have our second graph, and we need to manipulate that one as well. Okay, now let's have a look what's happening. And now you see that we have a complete and beautiful plot of our results. Our velocity starts at 0, our displacement starts at 0.01, and you can see the harmonic oscillation because we have no damping that it's going to be an oscillation which goes on forever. And now if we manipulate a little bit our initial conditions, so that we put in an initial velocity, for example 0.1, you can see that our plot adapts instantly. You can see also that the velocity now starts at 0.1. And that's all you should have learned from this lecture.